of nitrogen, this is where you gotta look at the periodic table.
There are
7.
There are 7.
So in N2 there'd be 14.
There'd be 14 because it's N2, because it's
Yeah.
diatomic.
Yeah.
Okay?
14.
Each nitrogen atom does have 7 electrons, but there's a total, because it's diatomic, there's 2 of them, so each one contains 14 electrons. So if you stop right now, what would you have?
Electron.
Total number of electrons, right? So then, if we come out here and go, okay, hey, 1 mole of electrons, or each electron contains how much charge?
1.60
Times 10 to the negative 19. So now if I multiply all that together, then that's going to give you the total amount of charge on 1 mole. So somebody do the math. Take 6.02 times 10 to the 23rd times 14 times 1.6 times 10 to the negative 19.
1,340. What?
1,000 what?
No, it's
Okay,
much
now
more than
1,000,000
1,000.
1,348,000.
How about scientific notation?
1.35 times 10 to the 6. Yep.
Coulombs.
10 to the negative 6.
So how much charge would there be on that number of protons?
The same.
That'd be the exact same, just be, instead of a negative charge, that would be a positive charge.
Maybe give or take an electron, you never know.
Now, sometimes you might get, it's kind of the reverse of this, it might say, you know something is charged to, so how many electrons are needed to produce a charge of 8 nanocoulombs, right? So that might be a situation where you take a charge sensor and you look at the balloon, and let's say that's charged to negative 8 nanocoulombs. So one of the things about charges, charge is either created by only one of 2 things. If you have a negatively charged particle, like a balloon, it's because you've added electrons to it. If you have a positively charged balloon, it's because you've taken electrons away from it. So you never add positive charge. You either add electrons or you remove electrons to create positive charge. It's like cations and anions in chemistry. Okay? You never add protons because of the fact that the protons are locked up. You don't change the number of St. Bernards because it's just too much effort. Okay? So you change the number of chihuahuas. So, let's say that you want to create 8 nanocoulombs of charge. You want to know how many electrons that's going to take, right? So what can you do?
Positrons.
Well, do you know how much charge there is on each electron? Yes. Well, if there was 8 nanocoulombs of charge on each electron, how many electrons would it take?
1.
1, right? If there was 2 nanocoulombs of charge per electron, it would take. So so how are you going to get your answer? What are you going to do?
Yeah.
Take the 8 nanocoulombs and divide that by what?
1.6 times 10 to the negative 10 nanocoulombs.
Times 10 to the negative 19th.
No.
You can do coulombs, okay?
Or negative
But
10
if you're going to do coulombs, now here's the beauty. This is the conversion that you'll use a lot, okay? Because nano means 10 to the negative 9th. So what I always do is I'm just going to write that, because if you take the 8 nanocoulombs and you go, oh, 1 nanocoulomb is 1 times 10 to the negative 9th coulombs. So this is why we use nanocoulombs so often in chemistry, or excuse me, in physics on this type of conversion. So the easiest thing to do is, instead of writing 8 nanocoulombs, is just come in here, because it means 10 to the negative 9th, and just write it as 10 to the negative 9th coulombs. Okay? So whenever you see nanocoulombs, just keep the number and put 10 to the negative 9th on it. Okay, that's if it had been 80 coulombs, you'd write it as 80 times 10 to the negative 9th.
5
Okay.
times 10 to 10 electrons.
So
Oh,
if you do this, you get
5
5 times 10 to the 10th electrons, because that's coulombs per electron. The coulombs cancel out. That flips out. Boom.
Are you
you're off
okay?
to the races. Okay. Okay, I feel like crap, and I can't talk.
Me too.
Be honest.
So here is.
Where did the parafluid go?
I mean,
But-
you don't have to give us an assignment if you don't want to.
Oh, it's not going to take very long. I just hurt right now.
In what way? Physically?
Just all over.
Emotionally?
It's not.
I mean, I just feel like,
Can we have a chance at the ferrofluid over here?
Yeah, Ryan kinda kept it forever, so.
So did you.
Oh, they
I
didn't
did.
see
I
it.
think
This
it was
entire
Ryan
half
who
of the room hasn't.
Oh,
did. It got as far as
there you
Ryan.
go.
There isn't really a.
Oh,
I
So,
must have. Wait.
Mia.
Oh!
Mia.
Oh. Well, that's little.
Oh, that's nice.
Well, that's nice, cause I got a bunch of calc to do tonight, so.
now, the other equation that you're gonna need is this, hold on, give me 1 second.
E equals.
So this is how you calculate charge on the force between two charged particles. It looks a lot like the gravitational equation does. Then this is just a product of your charges. This is how far away you are.
Let me guess, the K is a constant.
The K is just a constant.
Oh, this is the
Okay.
electromagnetic equivalence to the gravitational constant.
It is. So anyway, so you don't need that equation when you answer some of your questions.
kilograms, grams, and d squared.
Yeah.
Q is the charge, I'm gonna guess.
Yeah, Q is charges.
Yeah.
Point charge. It's like this one over here, but different.
Yeah.
Well, where's K?
No, it's
What is?
I require your acceleration.
Yeah, because they're both.
I require your
Oh, it's right here. This is actually it right here.
Oh, sorry.